First thing first is that just for the refreshment, for every training process in the simple neuron, so we will define the weight as W new equal to W old plus delta W. So delta W is very important parameters in order to be used for updating the weight accordingly. So we will use the same basic equation in order to update the backpropagation algorithms. Only for this particular case, our delta W will be constituted from two layers. The first one is the WJK, means that delta WJK, and then the second one is the delta WIJ. So I will start the first derivation of the backpropagation from the output layers until the hidden layers in order to determine delta WJK, so that we can calculate the new updated weight later on. So for this case, WJK new equal to WJK old plus change in delta WJK. So our aim is that we want to find what is the delta WJK for this particular condition by utilizing what we have derived from the forward pass. So according to the backpropagation algorithm, delta WJK is directly proportion to delta DE over dWJK, which is the rate of change of error with respect to the rate of change of WJK. So this is the relation. If you want to change from the relation to equal, so we need to define some constant parameters, which is it will become n dE over dWJK. So for the backpropagation algorithm, since we will assume that the new error will be less than the previous error, so this thing will cause the negative sign of the change of error with respect to the change of WJK. So our aim right now is to find what is the DE over dWJK from the forward pass. So how we able to find the relation is we will use what we call as the chain rule in order to find the relation from error in the output layer to feedback that things to the hidden layer. So first thing first, before we define the relation, we need to find what is the cost function. Cost function is the parameters that will be used in order to assess the performance of our neural network models. So there are many equations for the cost function, but for our case, we will use some simple sum square error cost function, which is defined as error will be half tk minus ok squared. So tk is actually the target of our samples minus ok. Ok is actually the y for this case, means that the predicted output at one state. So we will use this equation in order to feedback that things later on to determine what is the DE over dWJK. So right now we will start our derivation of chain rule in order to determine what is DE over dWJK. So DE over dWJK, if you want to find this relation directly from the forward pass, we can't find any relation that is from the error to the dWJK. So for this case, error related to the TK OK, and then OK related to the net K, and then a net K related to the WJK. So how we are able to relate all the three equations? We will utilize what we call as the chain rule. So in a simple way, the chain rule can be derived based on backpropagate the error from here until to this layer. So if you feedback the things here, first thing first is that you will find the net k, and then later on you'll find the OK. So that is the equation that we will utilize in order to derive the chain rule. So for this case, dE over dwjk can also be defined as, since first thing we will meet the net k before the OK, so we will define dE over dwjk as dE over d net k. Then since we will find back this original equation, we need to multiply this partial derivation with d net k over dwjk. Okay, for this equation, d net k over dwjk, you can actually find the relation in here from the forward pass equation. However, for dE over d net k, the relation is not direct, so we need to expand this part in order to find the relation. So as I mentioned previously, if we backpropagate the things, first we will face with the net k, later on we will meet the OK. So we can expand this thing by using dE over dok, and then times, we need to cancel out this thing, dok over d net k, which is the expansion from this part to this part, times d net k over dwjk. So for this case, dE over dok, you can find the relation in here. dok over d net k, you can find it here, and then d net k over dwjk, you can find it here. So our derivation of the chain rule is completed. So the next step is that how we able to find the output for this derivation process. So we label this thing as derivation part 1. This part is the derivation part 2, and then this part is the derivation of the part 3. So for the part 1, E is actually equal to half tk minus ok squared. So dE over dok can be defined as, we move the 2 in front over here, so it will become tk minus ok power of 1, and then we differentiate what is inside here. So dE over dok for tk, this thing will become 0, and this thing will become negative 1. So dE over dok equal to tk minus ok negative. So we are settled in terms of the number 1. So the next part, we will move to the second part of the derivation, which is we will find the second one. The second one is the dok over d net k. So I will place the thing near here so that you can see the second part of the derivation process. So for the second part of the derivation process, so OK is actually 1 over 1 plus E minus net k. So the dok over d net k, so this is the second part, will be equal to, so you need to differentiate this equation. So you can differentiate this thing by using 1 over 1 plus E minus net k squared. So you take this part, you differentiate the upper part, so it will become 0, minus, you take this part and then you differentiate the below part, so this thing will become 0 plus minus E minus net k so that you will have E minus net k over 1 plus E minus net k squared. So this is the derivation for this part. So however, we need to find this relation in terms of the output notation. So we need to manipulate a bit this particular equation in order to make this equation in terms of the OK naming convention. So if you still remember from this part, OK equal to 1 over 1 plus E minus net k. So OK equal to 1 plus E minus net k. So E minus net k will become 1 over OK minus 1, which is 1 minus OK over OK. So we can plug in this part to this particular equation. So in this case, E minus net k, we can take E minus net k equal to 1 minus OK over OK. So we are settling for the top part. So for the bottom part, 1 plus 1 minus E net k equal to OK. So for this case, it will be equal to OK squared. Okay, so now we can actually cancel out this part. So the whole equation, the final equation will become 1 minus OK times OK. So in this part, we are settled up until the second part of the chain rule derivation. So we move on to the final part, which is number 3 here. So number 3 is d net k over dwjk. So net k equal to summation of j oj wjk plus bk. So in this final part, this is part number 3, d net k over dwjk will be equal to oj straight away. So there are some reason for this case, because of if you expand the equation, let's say k equal to 3, and then j is the expansion of 2. So for this particular case, net 3, which is k equal to 3, equal to the summation, this is 2 times ojwj3 plus b3. So if we expand this equation 1 to 2, so it will become O1W13 plus O2W23 plus B3. So if you are interested in terms of d net 3, in this case d net 3 over delta W31, so you are left with O1. If you are interested d net 3 over dw23, then you are left with the O2. So for this particular reason, there is the reason why our output for the derivation in equation T equal to OJ. So now we have settled up in terms of the derivation of all the parts from the chain rule. So right now we just need to merge all the equation in order to determine the final output. So from here, so our dE over dwjk will become part 1. Part 1 is actually tk minus ok negative 1 times part 2 will be 1 minus OK times OK, and then part 3 is actually OJ. So finally, since our output that we wish to find is delta WJK, so in this case delta WJK is equal negative n d over dWJK equal to the whole part of this equation, Tk minus OK, negative 1 minus OK, OK, OJ. So this is negative, so all the things will become positive, and Tk minus OK, 1 minus OK, OK times OJ. So we are settled to derive the first part of the backpropagation algorithm, starting from the output layer to the hidden layer. So the next part is we will feed back from the output layer straight away to the hidden layer process.